Hello everyone, welcome to Reactify Labs. Today we will talk about fencing tokens. So before I start the technical part of it, let's see why we need fencing tokens or what is a real life example to relate to this fencing tokens. You must have gone to some amusement park like Wonderla or Imagica. So there are many people waiting for a ride there, right? So let's say this is the order in which people are there. So we know that okay, this person will go first, this will go second, and in the order these will go like this, right? So this makes sure that assigning an order to them, like uh, assigning them a token, basically we are assigning them a token, virtual token in that case, that we all know okay, whoever came in which order they will go in that order. So to make sure everyone gets a fair turn, each person gets a token, okay, and you can only get on this ride when your number comes, right? So that's it. In computer systems, fencing token is like that ticket. When different parts of the system need to use some shared resource, here the shared resource was that ride, right? So when different parts of the system need to use a shared resource, the system gives fencing tokens with unique numbers. These tokens ensure that only the right part can use the resource at the right time, thus preventing confusion and keeping everything in order, right? So let's say there are different nodes who are waiting to access on this shared resource, but as you know, the shared resource can be accessed by if it is accessed by only one party at a time, or if it's something like what do you say? Uh, if it's something which cannot be modified by more than one people at a time, then there will be a lock on it. And who will get lock in which order, that is decided by fencing tokens. So that's all there is about fencing tokens, if you have to relate it with your daily life and how it works in computers. So today we are going to talk about what are fencing tokens, why do we need fencing tokens, how fencing tokens work. We will also talk about how fencing tokens are implemented, what are the benefits of fencing tokens, and what are some of the real world examples where we can see, actually we cannot see, but we experience the systems we use, their fencing tokens are employed, okay. So that's it. Let's start with the introduction. So fencing tokens are a sophisticated mechanism sophisticated mechanism employed in distributed systems to order and synchronize operations. To order and synchronize operations, mitigating conflicts so that no two nodes fight that okay, it was my turn or my turn, okay. Mitigating conflicts and upholding data consistency so that data remains consistent. Why data consistency? Let's say if the predefined order is this one should use first, this should use second, and this should use third, and if fencing tokens were not there and this writes before this, then the order of write will be wrong, right? So this means if 2 is writing before 1, so after 2 had written then 1 writes, then this is stale data because 1 was supposed to write first, which would have been overridden by 2. But since they did not follow the order, the data consistency gets compromised. That's why fencing tokens are required. Okay. So fencing tokens are unique identifiers assigned to operations to establish a definitive sequence. So they act as unique identifiers. They act as unique identifiers assigned to operations to establish a definitive sequence. In distributed environments, fencing tokens play a pivotal role in ensuring correctness and preventing conflicts. They are crucial for maintaining the integrity of data across distributed nodes, contributing to the overall reliability and stability of the system. Now let's see, why do we need fencing tokens? So the need for fencing tokens. First one can be concurrency control. Fencing tokens serve as a powerful tool for managing concurrency in distributed systems. By providing a structured order to operations, they prevent conflicting updates from compromising data consistency, ensuring that operations are executed in a coordinated manner. So concurrency means different things are trying to write to a resource at the same time. So the order is determined by the number of fencing tokens, like the fencing token number assigned to that particular node, and if that order is followed, the data consistency is guaranteed. So concurrency control. Concurrency means accessing at the same time, and that is controlled. And second is preventing race conditions. Preventing race conditions. The unique identifiers assigned by fencing tokens are instrumental in preventing race conditions. These identifiers act as a barrier against conflicting operations, ensuring that each operation is uniquely identified and processed in a well-defined sequence. So if there is a particular order, then no two nodes will fight for a particular resource at the same time, and thus race condition will be avoided. Now let's talk about how fencing tokens work. How fencing tokens work. Fencing tokens operate by assigning a distinctive identifier to each operation or request. Okay, so there will be a distinct identifier, the unique identifier. This unique identifier serves as a fencing mechanism, creating a strict order for the execution of operations across distributed nodes. So this unique identifier, which is assigned to each node, this decides the order. This creates a strict order, right? So that's it. That's how the unique identifier works in fencing tokens. And there is one more thing called comparison mechanism, because if the unique identifiers are there, we need a comparison mechanism to know what is the order of which identifier. So comparison mechanism. Operations equipped with fencing tokens can compare their identifiers, facilitating the determination of their relative order in the distributed system. This comparison mechanism is fundamental for maintaining consistency and preventing conflicts. Let's take an example. So let's say there are three nodes. Node A. Actually, why am I writing node? Just write A, B, and C. So we have three nodes. And what fencing token does is, fencing tokens operate by assigning a unique identifier to each operation. So let's say operation 1. Operation 1 is performed on node A. It got the fencing token 1001. Operation 2 is performed on node B. It got the fencing token 1002. And operation 3 is performed on node C. Node C. and it got the fencing token 1003. Operations across nodes can compare their fencing tokens to establish a clear order. The higher the token value, the more recent the operation. So if we compare the three operations and their fencing tokens, we know that operation 3 will come after operation 2 and it will come after operation 1. So this is the order that should be followed, right? Okay. So let's take an example scenario of the some key value database. So this is it. That's it about the fencing tokens. So you get a higher number. If you get a higher number, it means your whatever you write takes precedence over any lower number. So example scenario. Let's say there is a database, which is a key value database. It's K. Key value database. So operation 1 comes first and it is performed on node A, and let's say there is a key 1 whose value is value underscore A. Okay, it changed the it assigned the value of key 1 to value A. Next comes operation 2. It is performed on node B, and not performed on, actually it's performed by node B, and what it does is it updates the value of key 2 to value underscore B. Now operation 3 comes and it is again performed by node A, and what it does is it updates key 1 to value underscore C. Okay, now actually here we have taken node C, right? So let's make it node C. Now what happens is, since operation 3 has the highest fencing token, it is considered the most recent. Therefore, its update takes precedence. So let's say what happens is, even when these nodes make their write, it is possible that due to some network delay, this node A's write did not reach. Okay, so this is where the database is. Node A wrote something and node C wrote something. Node A got delayed. And if node C has already written it and node B has already written it and then node A comes, then it is possible, it's very practical to assume that, okay, since this write came later, it means it must be the most recent write, right? Even if we see the timestamp of it, we'll see, yes, it is the most recent write. But when we see the fencing token, we will know that, okay, operation 1, which was performed by node A, had a lower fencing token than operation C, because only those two are performed on same key. So it means it has to be discarded. Operation 1 came after operation 3, then it must be discarded. There is no problem with key 2, because that key 2 is not compromised, it's not shared. Only key 1 was shared between two node operations. So that's why the key 1, so ultimately the value of key 1 will be value C and value of key 2 will be value B, and this will be the final state of the database, even though the operation 1 came later, right? I hope this explains clearly how fencing tokens work and why they are required. Okay, let's talk about some of the use cases now. First one, the most common one, would be distributed databases. Distributed databases leverage fencing tokens extensively to manage consistency and prevent conflicts during updates. The ordered sequence of operations ensures that each node processes updates in a coordinated fashion, thus preserving data integrity. This is the same example which I explained above. So databases use fencing tokens and they use that to manage consistency and thus preventing conflicts. The ordered sequence of operations ensures that the different nodes, perform their operation in their order. Even if some could not perform, A later one which has a higher precedence, if it has written already something, that cannot be overridden by a lower precedence node. Okay. File systems also. In the domain of distributed file systems, fencing tokens play a critical role in maintaining data integrity. They ensure that file updates occur in a controlled order, preventing discrepancies and conflicts that may arise from concurrent operations. Okay, now let's talk about implementing fencing tokens. Sorry. So first step in implementing fencing tokens is token generation, because if we have to use token, we need to generate it first. Fencing tokens are systematically generated for each operation, typically incorporating unique identifiers, timestamps, or a combination of factors. The process ensures that each token is distinct, thus avoiding conflicts in the operation order. Then next comes distribution and comparison. Distribution and comparison. So first let's talk about distribution mechanism. So fencing tokens are efficiently distributed across nodes within distributed systems to ensure a consistent and synchronized view. This distribution mechanism often involves a reliable communication protocol to transmit token information. So each node gets their own token. Okay. Next we do order determination, the comparison basically. It is also order determination. Nodes use the fencing tokens to precisely determine the order of operations. The comparison of tokens allows nodes to establish a coherent sequence, preventing conflicts and maintaining data consistency. Okay, so this is what we need in implementing fencing tokens. We need a token generation, we need a distribution mechanism, how to distribute the generated tokens to each node, and how to compare the tokens among nodes, or how to compare the nodes to check what is the order of operation for each node. Great. Now let's talk about the benefits of fencing tokens. We have already talked about why we need fencing tokens, but let's talk about it more in the benefits section. Benefits. First one, we have talked about it a lot now, ordered execution. So fencing tokens significantly contribute to maintaining data consistency by enforcing an ordered execution of operations. The ordered sequence ensures that updates are applied in a coordinated and consistent manner across distributed nodes. Next is coordinated updates. Coordinated updates prevent conflicting changes and discrepancies, fostering a stable and reliable data environment. Next comes preventing conflicts. Fencing tokens serve as a preventive measure against conflicts by establishing a clear order of operations. The ordered sequence minimizes the likelihood of data conflicts and inconsistencies, and thus enhancing the overall system reliability. Next comes ordered sequence. The ordered sequence facilitated by fencing tokens becomes instrumental in conflict resolution, ensuring that conflicting updates are minimized. And next comes reliability and predictability. Fencing tokens contribute to the overall stability of distributed systems by enhancing reliability and predictability. Reduced downtime and a more dependable system operation result from the prevention of conflicts and the establishment of a clear order of operations. So I believe now all the benefits of fencing tokens are clear. Fencing tokens ensure that the execution happen in a predefined order. The updates are coordinated among the different nodes. The conflict does not occur because of the missed order of execution. The sequence should always remain ordered, and the system should remain reliable and predictable. Okay. Great. Now let's talk about some of the real world examples. Real world examples. Oops. I need to make a new page. Okay. Actually, so first thing is orchestrating updates. Fencing tokens play a pivotal role in orchestrating updates within database clusters. They ensure that database nodes apply updates in a coordinated fashion and maintain data integrity in complex architectures. Next comes data processing. In cloud-based distributed systems, fencing tokens contribute significantly to data processing by maintaining order and consistency. Their adaptability to scalability challenges in dynamic cloud environments makes them a reliable choice for ensuring data reliability. Let's talk about different scenarios actually of real world examples only. So, scenario 1, high volume transactions in banking systems. High volume transactions in banking systems. So, what is the challenge? A banking system processes a high volume of concurrent transactions, including deposits, withdrawals, and fund transfers. Let's say you are a user of some bank, um, anything, maybe JPMC. It has millions of users. So everybody does something or the other at some point in time. So it's highly unlikely that when you are performing some operation on your bank account or database, you are the only one doing it. Every time there are concurrent updates. Okay. So what role does fencing token play here? Fencing tokens ensure that updates to account balances and transaction records are executed in a precise order. The ordered execution prevents scenarios where conflicting transactions might compromise the consistency of account data. Let's talk about second scenario. Scenario 2. E-commerce platforms with simultaneously changing inventory. E-commerce platform with simultaneous inventory changes. What is the challenge here? Obviously, as you know, e-commerce platforms like Amazon, they have millions of users, millions as in hundreds of millions of users, close to a billion users. And along with that, there are what do you say, sellers as well. And sellers keep updating their inventory. Like sellers are updating their inventory, users are buying, somebody else is doing something. So a lot of things happen, right? So an e-commerce platform experiences simultaneous updates to product inventory due to purchases, returns, restocking activities, different things go on. Fencing tokens orchestrate the order in which inventory changes are processed. This prevents situations where conflicting updates such as a sale and a return could lead to inaccurate stock levels or availability. Let's say you bought something, okay, and let's say initially the number was 100. You bought something, the number became 99. Then somebody else bought something, number became 98. Then you returned it, the number became again 99, right? So this number keeps on updating, like sometimes it's decreasing, sometimes it's increasing, sometimes it might be like, let's say it becomes 0 and somebody else wants to buy something, and what if it does not get updated, like it got sold but it did not get updated, so somebody else will be able to buy it, right? So that's what should not happen. If this buy order comes after a particular buy order which has already made the inventory 0, it should not be executed. So this is where fencing tokens play a very important role. So that's all there was about fencing tokens. I hope this gives you a good understanding of how fencing tokens work, what are fencing tokens, why do we need them, and how important they are in our daily life to make the distributed systems um, help maintain data consistency, strong consistency basically. So that's it. Thank you for watching. Please remember to like, share, and subscribe. I will see you in the next one.